Hello, today I'm going to do a past few IB multiple choice questions from the topic 5, which is energetics or thermochemistry. So if you want me to keep doing it, please share, like and subscribe to my channel. In this question, it is asking which statement is correct for this reaction. So as per the reaction, 1 mole of Fe2O3 reacts with 3 moles of carbon monoxide to give 2 moles of iron and 3 moles of carbon dioxide. Now the energy released in this process is 26.6 kilojoules. Why did I say energy released? Because delta H is negative, so it is an exothermic reaction. And they are comparing the energy released in terms of Fe. So if we look at Fe, 2 moles of iron is producing 26.6 kilojoules of energy. So for every mole, which is 1 mole of iron, is going to produce how much of energy? To do this question, we'll have 2x is equal to 26.6 and x is equal to 26.6 divided by 2. So this gives us 13.3 kilojoules. So our correct option for this question is 13.3 kilojoules are released for every 1 mole of iron produced. This is the right answer. In this next question, it is saying the enthalpy changes for two reactions are given to us. So for one of them, it is x kilojoules and for the other, it is y kilojoules. And now we have to find the enthalpy change for this reaction. So this is an application of the Hess's law. So to do this question, we'll look into our target equation. So target equation has BRF, bromine fluoride, as the first reactant. We have it over here. We want it on the left. We have it on the right. So we need to flip the equation number 1 and we want only 1 mole. We have been provided with 2 moles. So flip and divide by a 2. Now, the next reactant in a target equation is F2, which is present in 2 equations. So let us right now not be focused on this. The third product in our target equation is BRF3. We have it here in the second reaction. We need it on the right. It is on the right. We need 1 mole. We have been given 2 moles. So which means the second equation also, we just need to divide by a 2. And then if we add the 2 equations, you can see we'll get the target equation. So let us do it. So if we flip the first equation, which means the change reactants into products and products into reactants, we'll have BRF, 1 mole of it gives us half BR2 and half F2. So I flipped and I divided by a 2. Now I'm going to take the second equation and divide it by a 2 as well. So we have half BR2 plus 3 over 2 F2 gives us BRF3. Now, when we divided the first equation by a 2 and flip it, its delta H is equal to negative x over 2 kilojoules. And when we divide the second reaction by a 2, the delta H for that is equal to y over 2. Now, if we add these 2 equations, the BR2's half and half get cancelled. And now we have BRF on the left. This half F2, when moved on to the left-hand side, gives us 3 over 2 minus half. So 3 over 2 minus 1 over 2 is 2 over 2, which gives us a 1 F2. and gives us, we are left with only one product on the right, which is BRF3. So you can see that that's a required target equation. Now to get the resultant delta H value, we just need to have negative x over 2 plus y over 2 as the delta H of our target equation, and this matches option C. So half is taken common and negative x plus y is left in the bracket. So option C is the right answer. In this question, it is asking us what is the enthalpy change in kilojoules for the following reaction. The reaction is given to us for the formation of ammonia, and we've been given the bond enthalpy. So keep in mind, when the bond enthalpies are given to us, to find the delta H, we need to draw the Lewis structures of each of the reactants and products. So we'll have 3 H2s plus a nitrogen molecule, and that giving us 2 moles of ammonia. Though I have drawn the Lewis structures for each one of them, but we are really not worried about the lone pairs over here. So here to find the delta H, we'll have the sum of all the bond enthalpies of reactants minus the sum of all the bond enthalpies for the product. So these have to be multiplied by the number of moles of each of the bonds involved. So we can see that on the reactant side, we have one hydrogen bond with us, which is like a single bond, but 3 of them. So we'll take this value 436 and multiply it by a 3 plus another bond which is involved in the reactant side is nitrogen triple bond. So we'll take this and just add, so 965, and now subtract the bond enthalpies of the bonds involved on the product side. So we have 3 NH bond in ammonia, and just because 2 molecules are there, so we have a total of 6 bonds here, which means it is going to be 6 multiplied by the bond enthalpy of the nitrogen-hydrogen bond is 391, so multiplied by 391, and this should be the answer in kilojoules. So if we try to match it, it matches with option D. The only difference is here, this part has been written first and then this part has been written later. So our right answer is the option D. For our next question, it says which expression gives the mass in grams of ethanol required to produce 683.5 kilojoules of heat upon complete combustion. So first we are going to write the chemical reaction for the complete combustion of ethanol. So this is going to be C2H5OH plus O2. This gives us CO2 and H2O. Now we have to balance this chemical equation. Carbons are 2 on the left. We'll have 2 carbons on the right. Hydrogens are 5 plus 1, 6 on the left. So we'll make it 6 on the right. Now oxygens are 2 times 2, 4 plus 3, 7, out of which we already have 1 oxygen over here. So we can put a 3 over here, 3 times 2, 6 plus 1, 7. So this is our balanced chemical equation. And they have given you the delta H of combustion. So delta H for this reaction is negative 1367 kilojoules per mole of ethanol. So it is fine because we have only 1 mole of ethanol. Now 1 mole of ethanol, we'll change it into mass because they are asking us the expression in mass in grams of ethanol. So what we're going to do is the molar mass of ethanol is going to be 46 grams per mole. So we can check this out from the periodic table. Carbon approximately 12 times 2 plus hydrogen 1 times 5 plus 16 plus 1 gives us 46 grams per mole. Now 46 grams of ethanol produces 1367 kilojoules of energy. So we have been asked how much mass will produce this much kilojoules. So the mass is x grams and the energy proportionally is 683.5 kilojoules. If we want to solve for x, it is going to be 46 multiplied by 683.5 divided by 1367. So that is going to be our value of x. So which matches C? So C is the correct option for this question. In this question, it is saying what can be deduced from this reaction profile. So from this reaction profile, we can see that the energy of the products is lower than that of the energy of the reactants, and when the enthalpy of the products is less than the enthalpy of the reactants, in that case the reaction is exothermic. So if the products have a lower enthalpy, hence they are more stable. We are doing that because the question is asking in terms of stability. So products having lower enthalpy are more stable and the reaction is exothermic. So our correct option is option number A, in which the reactants are less stable, which means the products are more stable and the reaction is exothermic. For this question, it is asking why is the value of the enthalpy change for the reaction, which is calculated from Bond enthalpy data, less accurate from the standard enthalpies of formation. We know that we can calculate the enthalpy change by using the Bond enthalpy data as well as the enthalpies of formation. But keep in mind that the Bond enthalpy data, the name itself, it says that it is average Bond enthalpy, because if I consider CH4, then not all the CH bonds have the same amount of energy. Each bond to be broken down will require a different amount of energy, and hence when we are using average, which means the value is not going to be that accurate, which means the right option for this answer is option number B, where it says Bond enthalpy data. It has got average values of many compounds. For this question, it is asking which change of state is exothermic. So the change is always exothermic when the reactants are at a higher energy state and the products are at a lower energy state. So out of all of these, we can clearly visualize that a high energy state to a low energy state is going to be for option C, because the particles of the gases are more energetic in comparison to the particles in a liquid, and hence option C will have the change as exothermic. In a similar question, this says, in which reaction do the reactants have a lower potential energy than the products? So for the reactants to have a lower potential energy than the products, the reactants need to be less energetic, and for that the right option is option B, because all of these are gases, but on the reactant side we have only 1 mole of the gas, and on the product side we have 2 moles of gases. So which means we are going from the lower energy state to the higher energy state. Hence, option B is the right answer for this one. For this question, it is asking which equation represents the standard enthalpy of formation of liquid methanol. So the formula for methanol is CH3OH. And liquid methanol, so it needs to be in liquid state. Formation means it has to be on the right hand side as a product, and it needs to be 1 mole. Now you have to keep in mind that the enthalpy of formation is the formation of 1 mole of a substance from its elements. So this methanol is made up of carbon, it is made up of hydrogen and oxygen. So they all need to be in their elemental state. We cannot have this atomic state for oxygen or atomic state for hydrogen. So these options are not going to work. Now, if we want to have a balanced chemical equation, carbon usually exists in solid state. For hydrogen, we need to have a gas, but on the right hand side, we have 4 atoms, so we need to balance it out. And here oxygen, we have only 1, so here we need to add a half to get 1 mole of oxygen. So our correct option for this question is option D. We cannot have option A because here carbon is written in gaseous state. Carbon in its standard state is in solid state. So option D is correct. I hope you understood and enjoyed the video. See you in the next one. Bye-bye.